Hello everyone, my name is ialalani and today we will be talking about Confluence Server Webwork OGNL injection attack based on CVE 2021-26084. Alright, before we talk about the attack, let's talk about what is OGNL injection. So OGNL injection basically stands for Object Graph Navigation Language, which is an open source expression language for the Java objects. It is mainly and specifically focused on enabling the evaluation of expression language in Apache struts, which is also used for the development of framework for Java-based web applications in enterprise environments. Now, the most critical vulnerability of the Apache Struts CVE are all related to the OGNL expression injection attacks. It enables the evaluation of invalidated expression against the value stack and allows an attacker to modify system variables or execute any arbitrary code. As OGNL has the ability to create or change any executable code, it is also capable to introduce any critical security flaws to the framework that uses it. So, protection against this vulnerability requires security solutions that will be able to detect the presence of vulnerable struts to components in the software so that attacks can be prevented. All right. So as we know that HTTP is a request response protocol. Now a request is sent by the client to a server, which in turn sends a response back to the client. HTTP requests consist of a request line, various headers, an empty line, and an optional message body like is shown here. So here the CRLF represents the new line sequence carriage return CR followed by the line feed, and SP here represents a space character. So parameters can be passed from the client to the server as name value pairs in either the request URI or in the message body, depending on the method used and the content type header. For example, an HTTP request passing a parameter name param with value 1 using the get method looks like this. And a corresponding HTTP request using the post method will look like this. Alright, so talking about the vulnerability, the Atlassian Confluence is a collaboration platform which is written in Java. Users can create content using spaces, pages, and blogs that others can comment on or edit it. Now, it is written primarily in Java and runs on a bundled Apache Tomcat application server, which is by default accessible via port 8090 for TCP. Now, Confluences uses the WebWork application framework to map URLs to Java classes, creating what is a known as action. So each action creates or sorry, each action entry contains at least a name attribute, defining the action name, a class attribute, defining the Java class implementing the action, and at least one result element which decides the velocity template to render after the action is invoked based on the result of the action. Now, common return values from these actions are either error, input, and success, but any value may be used if there is a matching result element in the associated xwork XML file. When no command is specified, the do default method of the action class is called. Now, Confluence supports the use of Object Graph Navigation Language (OGNL) expressions to dynamically generate web page content from velocity templates using the WebWork library. Now, OGNL expression contain strings combined to form a navigation chain. The strings can be either property names, method calls, array indices, and other characters. So OGNL expressions are evaluated against the initial or root context object supplied to the evaluator in the form of the OGNL context. It can also be parsed using the OGNL parser expression method. Now, the OGNL.javachar method is called the OGNL parser because it evaluates Unicode escape characters in the form of \u four x's. So now here the four x's are the hexadecimal code of the Unicode character represented. Therefore, if an expression includes any character like \u0027, the character is evaluated as a closing character, like a closing quote character like this. Um, this is because it escapes the context of evaluation as a string literally and allowing it to append an arbitrary OGNL expression. If an OGNL expression is parsed in a velocity template within single quotes and the expression's value is obtained from the user input without any sanitization, then an arbitrary OGNL expression can be easily injected. An OGNL injection vulnerability already exists in the Atlassian Confluence. The vulnerability is due to insufficient validation of the user input and is used to set variables evaluated in the velocity template within single quotes, as we talked about. By including the /0027 character in user input, an attacker can escape the string literal and append the arbitrary OGNL expressions as talked about. Now, before an OGNL expressions are evaluated by web work, they are compared against a list of unsafe node types, property names, method names, and variable names. However, this is not exhaustive, and arbitrary Java codes can be represented even without using any of the unsafe elements listed. Now, based on this picture, we can say that a remote attacker can exploit this vulnerability by sending a crafted HTTP request which contains a malicious parameter to a vulnerable server. Successful exploitation can result in the execution of arbitrary codes with the privileges of the server. Remote detection of generic attacks. Now, in order to detect these types of attacks, one should monitor all the HTTP traffic requests where the path component of the request URI contains one of the strings in the URI path column in the table shown here. And if such a type of request is formed, the HTTP request method should be inspected. If the request method is posed, we should be looking for the respective vulnerable parameters from the table in the body of the HTTP request. And if the request method is get, we should look for the parameters in the request URI of the HTTP request. Now, we should also check to see if the value of any of the vulnerable parameters contains the string \u0027 or its encoded URL encoded form. Uh, if so, the traffic should be considered malicious as an attack exploiting this vulnerability is likely to take place. For conclusion, Atlassian patched this vulnerability on August 25, 2021. A thorough analysis of this vulnerability was provided by Guy Lederfin and Yazi Wang of the Trend Micro Research team. Since the initial publication of the advisory, they have updated it multiple times to note the active attacks and to add clarification on how customers can actually identify if they are using Confluence Cloud. Uh, They have also said, they have also listed some of the mitigations, but considering on how widespread this bug is currently being exploited, the best course of action to apply is to apply the patch that have been released and enhance the system monitoring. Thank you and stay safe.